Hello, I am Devadarshi Das Mahapatra. I am part of the engineering chemistry project group number 4, and along with Pavan, Chandu, and Sarans, and we are here to present a video on adhesives. So, we tried our best doing this. We really didn't like this is our first time doing so I hope this would be I mean let's get over that. Adhesives, what are exactly adhesives? Wikipedia says that adhesives are known as, or adhesives or otherwise known as glues, cement, mucilage or paste, or it is any non-metallic substance that is applied to one or two surfaces of two separate items that binds them together and resists their separation. So that is what Wikipedia says. So technically speaking, or in the layman's terms, adhesive is something that binds two things together, right? We have done a few activities. One of us has done, like, each of us has done a couple of activities, and then we have presented it in a way that shows how we have understood adhesives as practical items, or as a practical thing that we use in our day-to-day lives. And there are multiple forms of adhesives. There are organic, they are inorganic. Of course, there's a fundamental difference between few things like adhesives, or there's sewing, there's mechanical fastenings, there's welding. So that's a different form of adhesives. We are not going to talk about that. The adhesives that we fundamentally know to be using for something like Fevicol, Fevikwik, Araldite, the Scotch tape or sellotape even. And we'd like to talk about those and one or few more things that we know about adhesives in itself. The following activities that we have presented in our video will probably clear our stance on that, and hope you'll enjoy it. I'll come back later. Thank you.
Now I would like to show you how araldite is used to stick two things like this is two steel things or two iron things together. First, I want to tell you that araldite comes with two tubes. One is the resin, one is the hardener, and as you can see, this is uh, this is the hardener. It's written on the back, and this is the resin. As I said, it's the epoxy resin. So now take equal amounts of resin and the hardener and mix it until it forms a uniform color. I'm taking just a little bit because I need little amounts of resin and the hardener side by side and then mix it together. Just taken 2-3 drops of it and like try to mix it until you get it uniformly. Araldite adhesive sets by the interaction of resin and the hardener, so we are mixing it together. Heat is not necessary, although heating it would strengthen the bond. And now take this slightly and put it on the surface. And do it with this other thing too. Just put it where do you want to stick it. Just applying it on the top. And just put this together, these two things together. And we need to leave it for an hour or two to stick them properly together. This will be strong, long lasting, solvent free adhesive which is water resistant and can be painted or sanded. This is perfect for jobs on metal. Now I would like to show you an interesting thing about like when we mix Fevicol and Fevikwik together, what happens? Does it act as a super glue, or let's see what happens. Just a second. So I have my glue Fevicol here, and now I'll mix it with Fevikwik. I'm pouring Fevikwik on this. So from a layman perspective, like it should be acting as a super glue, but let us see what happens. I just pour some more. So now let's mix this together by using something. Basically here, as you can see it, the Fevicol is sticking to itself and forming a thin layer because of the Fevikwik. So the Fevikwik is sticking the Fevicol particles together. That's why we are able to see this together and not running away. As you can see, it's a layer that's formed here, exactly right here. So now I'll try to apply this on wood and see if what happens. Does this stick together or not? I'm just trying to join two wooden pieces together, like two plywood pieces together. But as you can see, if it, if it had been either Fevicol or Fevikwik, it would have stick together. But now, as you can see, it can't stick together. So if you add Fevikwik and Fevicol together, this happens. It doesn't stick.
Hi, I'm Saransh Mishra and I'm doing chemical engineering with MSc Mathematics. So my friend Pawan talked about some adhesives that involve chemical bond formation. So I was thinking for some real life example in our daily routine. So one that came into my mind was related to cooking. So we have those stainless steel pans which are quite sticky. They don't have any Teflon coating on it. So what happens is when we try to cook anything on it, like for example omelette, without using cooking oil or ghee, so the food particles sticks to the material, the surface of the pan, and this is due to the bond formation between the protein in that food and the metal. They form a complex ion. So let's go to the kitchen and try to understand the reason behind it. And I have a non-sticky pan also, which which has a Teflon coating on it. So the difference between these two pan, and how can we make a sticky pan into a non-sticky pan. So with us we have two types of pans. So this one is the sticky one, the normal stainless steel pan, and this one is the non-sticky one, the with the Teflon coating. So the shape of the liquid or the food item, for example, we are trying to make an omelette. So the shape of that food depends on the type of material and the smoothness of the surface. So in this case, stainless steel, so it has a lot of pores. In microscopic level it might look smooth on the surface, but it has a lot of pores. So placed on the surface of the pan. So the relative strength of adhesive and cohesive force depends the shape that liquid will take. So in this case, the adhesive force is stronger, is way more dominant than the cohesive force. So when we keep the food on the pan surface, what happens is it occupies all the microscopic pores, small pores it has, and the food that sticks to the surface, it is because of the chemical bond which is formed between the food and the material of the pan. So we can also make it a non-sticky pan by adding cooking oil or ghee. So what it does is it occupy the oil occupies all the microscopic pores and it makes the surface smooth. So now I will show you by making a omelette on a sticky pan, and after that on non-sticky pan. So we can prevent the food from sticking by adding ghee or cooking oil, or by moving the food item so that the bond formation can be prevented. As you can see, the food sticks to the pan due to chemical bonds that occur between the food and the material of the pan. Though these bonds are going to be weak as the van der Waals forces, but they're enough to cause the stickiness. Especially protein rich foods are particularly prone to sticking as the proteins can form complexes with metal ions, such as iron, in the pan. So the special coating on the non-sticky pan, Teflon, keeps the food from bonding to the surface of the pan. In these non-sticky pans, there is a coating of Teflon on the surface. So if you see the compound Teflon, all the bonding site of carbon is taken by the fluorine and the carbon. So none left to form any bond between the food molecules and the surface. So if the adhesive force between the food molecules.
Everyone, now, as previously discussed, now we are going to make the household adhesives. For this, we need flour and sugar. We need to add some water, and we also need vinegar to make this more effective. We will add vinegar. Firstly, why we are using flour is that it makes the hydrogen bond very effective. This glue, here we make this glue because of this hydrogen bonds. It attaches the substances also very well. Now I am adding water to it. Then I am adding a little sugar too. Need to mix this very well so that these won't forms any clusters, means clumsiness shouldn't be there. It should be very loose. The sugar too should dissolve into it. There are many other methods to make these adhesives, that is like glues into in home. One is we can make it through. Now I'm adding water into it should be a little warm so that won't these won't stick together, means the lumps won't be formed if it is a little bit hot. So after some time we need to add into this, such as I was telling about various methods, such as we can make it through milk too. If we add vinegar into milk, and then we can separate fat from it, and that fat coming from this milk, we can heat it and then use it when we want as a glue. And also now it's a little warm, so that now we can add completely, so that these lumpsomeness won't be formed. Now we need to mix it very carefully, or else it sticks into the pan. These lump sum nests shouldn't be formed here. So we should make sure that these are very little. These are formed very little here, or else we are unable to join these. We need to be very careful here, so or else these lump sumness makes the glue very inactive. These glue doesn't act very well in the when we attach them. Means it sticks to itself. It doesn't stick to the substance we are caring for. The water must drain completely, or else it's no use of making this. There are many other methods we can do this, such as we can make these petrol and from we can make these adhesives from petrol and thermocol. When we add thermocol into petrol, thermocol dissolves into petrol to make it as a glue. These are mainly used in pipes like that. Now we are going to take it in a bowl. Once it is completed, see here, you if you observe carefully you can find the things attached to the pan. See here you, because of this the hydrogen bonds between the substances itself, means it attaches to the substance itself. These are very effective here. We need to be very careful in this stage. Now we can add a little vinegar. Just a small spoon will be enough. Because these make that more adhesive towards its nature, means it attaches very quickly if we add vinegar to this, or else it takes a lot of time to attach this. We need to mix it properly so that the vinegar will be staying at a single point. See this now, should form like this. See here. Yeah, I'm stopping now. Yeah, now this is the cloth, and now I will be attaching this to a take a little. See this, you can observe this like a, it's like glue. You can attach many things, but I don't have like this a paper. It attaches as usual, so I am making somewhat change to make that This is more stronger than we think as a glue. Takes some 5 to 10 minutes. In that we can attach some other to these buttons to means because it takes time because it's lacks of water. It should drain, the water should drain here. See here we got nice. That will be fine, I guess. Now if you wait for 5-10 minutes, it will be completed. We will upload this photo once we are done with it. We can't extend this that long, so my next person will be proceeding about his topics. Thank you. The previous activity, now I'm going to discuss it in detail about the petrol and thermocol issue, and same as milk. This thermocol is made up of this polystyrene, which is a chain of carbon atoms, 1 3 5 etc like this, and then when you dissolve this thermocol into petrol, it dissolves, it doesn't react, any reaction takes place between the petrol and thermocol, which results in a formation of glue. Now coming on to the milk has a protein content that is known as casein, everyone knows, and this casein is almost one third of the milk you purchased. And this casein, these can be separated and make it as a adhesive by adding vinegar to it, so that you can separate this the liquid in the milk and the this casein separately. And this casein is heated a little bit so that the water comes out of it, and then this a small amount of baking soda is added into it to make it more adhesive. And then it is it should be under pressure till the water is completely drained out.
So, hello again. Um, I hope you liked the videos, the activities that we did. I did my best to edit out all noises, the camera angles, the exposures, and everything. So, I hope the editing was at par as well. And I mean, we talked about, let's go about the content. We talked about the super glue. It was Pavan there. Chandu did the lump formation, the cohesion, the adhesion there as well. And then there was Sharan's doing the Teflon, showing the activity of Teflon using that very well made omelette there. Okay. Um, I did not do an activity because I hope they covered all of these. Because we kind of covered all of the activities that we kind of wanted to show other people and maybe ease people through the section of adhesives in general. Coming back, we saw inorganic, as I talked in my first part, in the introduction part, the inorganics and organic adhesives, right? um, Inorganics are cool. Inorganic adhesives are pretty much the part of our daily life. We use a Fevicol, we use a sellotape, we use pretty much everywhere, right? And then there are organic. So that begets a question: why are we not using organic adhesives in our daily life? Well, I mean, we kind of do, as we know, but then not always, and that kind of gives out the feeling that we are not very environmentally conscious or something, right? So I guess we could switch to organic adhesives. We need to do some kind of research. It's obviously research is going on organic adhesives, and people are kind of using those. Those are being manufactured as well. Um, but there needs to be a paradigm shift there, to in response to the changes in the environment, the pollution of environment and biodegradables or something. I'll not go into the details of that. But as students of engineering chemistry, we who are studying things in this field, we need to put in a conscious effort if we are to continue to invest or our knowledge in the field of adhesives, and that needs to be towards forming or constructing or using, or rather discovering, the use of organic adhesives and on a more widespread scale, so as to prevent not the use of non-biodegradable items in the production, and in eventually in the final practical use of the adhesives there. And I think we kind of missed out along words. I think we kind of missed out on a few things like cohesion, or maybe let's say sellotape use, the use of sellotape. We did not show that activity there, and sellotapes are pretty much part of our lives, uh, almost every day. It's kind of used every day. And Karthik sir had asked us, and in his video, in his little video clip in our WhatsApp group, he had asked us to talk about scourge tapes, but I feel that we kind of left it out because we pretty much know about it. So it's not a very genuine reason to do so, but uh, we kind of like to keep it short and cover more on the activities that we actually wanted to show and people did not know about it, or rather did not pay attention to it. uh, Hopefully you'll pardon us for that, and also pardon us for the limited editing knowledge that we implied. So of course I cannot um, did not include match cuts or those jump cuts that we usually see in movies. Those the professional kind of editing that goes there. It was a very amateurish video, but with kind of like clipping into with some bit of fading in and fading out. But I hope that kind of gets it home. Hope you enjoyed the video. And of course, it's part of the evaluative component, so I hope Karthik sir will be sort of impressed by it, or rather not get disappointed by it, and we get some marks there as well. Thank you. And signing off, Sharans, Pavan, Chandu, and me, Devadarshi. Thank you.